Hello again, this is Mel. Today we're going to talk about the correlation game applet, which explores the linear association between two quantitative variables. I'll show you how to play this game and how to use this applet to explore the concept of correlation. You can find the correlation game here. This applet displays a scatter plot of two quantitative variables. At the top right, you can see the current correlation of the plot and the target correlation. The objective of this game is to match your correlation with the target correlation. You can change the scatter plot by adding points. As you can see, adding points changes your correlation. However, you don't have an infinite number of points. At the top right, the number of moves you have left is displayed. At higher difficulty settings, you have fewer moves to match your correlation with the target correlation. However, let's start at an easy difficulty level. Based on this scatter plot, I think there is a linear association between x and y. This is reflected in the current correlation. It's 0.97, which indicates a strong linear association. However, we have to add points to decrease the correlation to 0.21. How might we do that? Where should we add points? Let's think about what the correlation statistic means. We know it has something to do with clustering around the standard deviation line, the line which passes through the point of averages and has a slope SD of y over SD of x. But there's a more formal mathematical definition. To calculate the correlation, you first standardize the x values standardize the y values, and then take the average of their products. Okay, so how does this tell us where we should add points? Well, we can display the mean of x and the mean of y on the scatter plot. This divides the scatter plot into 4 quadrants. In this top right quadrant, we see that standardized values of x will be positive because it's higher than the mean of x. Standardized values of y will also be positive because they're higher than the mean of y. Their product will be positive. This contributes a positive value to the average. In this bottom left quadrant, we see that both standardized values will be negative, so their product will be positive. This contributes a positive value to the average. In this bottom right quadrant, we see that the standardized x value is positive, but the standardized y value is negative. Their product is negative, and that contributes a negative value to the average. And for this top left quadrant, the product is also negative. Since our current correlation is 0.97 and our target correlation is 0.21, this suggests to me that we need to make the correlation more negative. As you can see, by adding points in the two negative quadrants, we decrease the correlation, and finally, we win. Okay, let's try something more difficult. But first, looking at the scatter plot, do you think that correlation is a good way of describing the association between x and y? Personally, I think the answer is no. I think there's a pretty clear quadratic association between x and y. But we can try to play the game anyway. We see that our target correlation is negative 0.76, and our current correlation is 0.84. We can only add 4 points, and we have a long way to go. So I'm going to add points to the two negative quadrants I'm going to add them as extreme as I can get them. So as you can see, we're making good progress. Unfortunately, much like life, at the hard difficulty, it's not always possible to reach your targets. Okay, so to summarize, we looked at scatter plots as a way of describing the relationship between two quantitative variables, and we also considered correlation as a measure of the linear association between these two variables. I hope you enjoyed watching this video and find it useful in your curriculum. Again, if you have any comments or suggestions I might incorporate into this applet, feel free to contact me at mao.hu@duke.edu. Thanks for watching.